Hello, this is Mrs. Poland for AP Statistics. In this video, I'm going to go over several more problems from the Chapter 2 review sheet. Let's go over number 11. The distribution of lengths of salmon from a certain river is approximately normal with a standard deviation of 3.5 inches. If 10% of the salmon are longer than 30 inches, which of the following is closest to the mean of the distribution? So let's look at the information we have. We know we have a normal distribution. We don't know the mean. In fact, that's what the question is asking us to find, but we do know the standard deviation is 3.5. When you're looking for either the mean or the standard deviation or both, that's when we know we use the inverse norm to find the z-score and the z-score formula to back into either the mean or the standard deviation. So next, draw the diagram. So we have the mean in the middle, and the score of 30 I know is, since they say longer than 30 inches, that's how I know I'm going to be looking to the right, and that 10% really is the 90th percentile. So let me just continue marking up the distributions. So this is 0.10, and a fish of 30 or more is in that top 10%. So I'm going to find the standardized score, the z-score for that fish that's a length of 30. And so we're going to do inverse norm. But remember, when you're using inverse norm, you need the percentile. So if you're in the top 10%, you're in the 90th percentile, 1 minus 0.10. And again, we're finding a z-score, so that's why you're inputting the percentile. The mean of the z-score is 0, and the standard deviation is 1. So let's go into our calculator, and we're going to go to a calculator page. You do menu, statistics, distributions, inverse norm, and we're going to enter 0.9, 0, 1. And we get 1.28. And I normally do z-scores to the nearest hundredth. Sometimes I do 3 places. In any case, in this case, I'm going to do 1.28. I'm now going to apply the z-score formula. And in this case, we know the z-score is 1.28. We know the data value is 30. The mean is what we're looking for, and then the standard deviation is 3.5. Now, you can solve this algebraically, but you most certainly can use NSOLVE in this course, because the focus of this course is on the statistics and the analyzing of problems versus the algebra. So either or is fine, but just since some of you are new to NSOLVE, I'll just make sure to write out the command line, though you do not need to write out the command line for NSOLVE on a test. So what you would do is you would enter the equation, make sure it has an equal sign, and you would have to replace the mu with an x. And this is where most people forget. You have to put a comma and then the variable name, x, otherwise NSOLVE doesn't work. So we're going to do menu, algebra, numerical solve. That's what NSOLVE is. It's in the algebra menu. So it's 1.28 is equal to, the equal function is on the same line as 789. And then it's control division gives you that fancy frac. And it's 30 minus the mean x over the standard deviation of 3.5. And then comma x. And hit enter, and you get 25.52. Which is about 26 inches. Okay. The next problem I'd like to go over is something similar, and that's number 13. The weights of adult men in a hypothetical population are approximately normal with a mean of 168 pounds, and a standard deviation of 8. Tom's in the top 8%. What is the approximate weight in pounds? So this is a little simpler than the other problem. It's not two-step, but the reason why I wanted to do this is an example of when you want to use inverse norm. So we know the mean is 168. We know that Tom is in the top 8%. So we're given a percentage. When you're given a percentage and you want to find either an actual data value or a z-score, that's when you use inverse norm. So here's 0.08. Remember, when you're using inverse norm, you need a parameter to be the percentile. Couldn't get the words out just now. So the percentile, if you're in the top 8%, is 1 minus 0.08 or 0.92. So this would be 0.92, the mean, and the standard deviation. If this was a free response, you would have to annotate the calculator command line. So we're going to go into our calculator. We're going to do menu, statistics, distributions, inverse norm, and you're going to type in 0.92. Hold on. Let me just get out the review sheet because I forgot the values. 168 and 18. So and you get 193. So this would be 193 pounds. Okay, I'd like to go over example 14. If the heights of 99.7% of Americans are between 5 feet and 7 feet, what is your estimate of the standard deviation of the heights of adult men? And you really have to pay close attention to the choices because all these values are in terms of inches. Yet the data values are in terms of feet. So you either have to convert the standard deviation to feet or the feet to inches. And I'm going to choose to convert the feet to inches. There's 12 inches in a foot. So if I go 5 times 12, someone who's 5 foot is 60 inches, and 7 times 12 is 84. Inches. I'm going to make my diagram. My mean's in the middle, and we don't know our mean. That's what we want to find. But we don't need to use normal CDF. And the reason why is if you recall the empirical rule, when you hear 99.7, you should be thinking 3 standard deviations from the mean. So this is 1, 2, 3 above, 1, 2, and 3 below. And 3 below you had 60 inches, and 3 above you have 84 inches. Now all these standard deviations are the same. And so what you can do is you can calculate the standard deviation first by saying there's 1, 2, 3, 4, 5, 6. There's 6 standard deviations, and between 84 and 60. So 6 theta is equal to 24. Theta is equal to 4. Oh, that's what they wanted. They didn't want the mean. I read mean as men. So they just wanted the standard deviation, and that would be 4 standard deviations. Okay. There were a Couple of other problems that I'd like to do. I'd like to do 16 and 17. A sleep time of 15.9 hours per day for a baby is in the 10th percentile. Again, even before I continue, I draw it out. So there's some sort of mean. In fact, I'm looking for the mean. I'm given the standard deviation as 30 minutes or a half an hour. Okay. And I'm looking for the mean. So here's mean. But a baby that's sleeping 15.9 hours is in the 10th percentile. So that's my X value. And they gave me a percentage. And they want you to find the mean. Again, anytime you're looking for the mean and or the standard deviation or both, it's that two-step process where you first find the z-score of the data value. So I need to find this z-score. And to do that, I'm going to use inverse norm. So I do inverse norm, and I don't have to subtract from 1 because they gave me the percentile in this case, and then 0, 1. So I'm going to go to a new calculator screen, and I'm going to do menu, statistics, distributions, inverse norm, 0.1. The mean is 0, the standard deviation is 1 for a z-score, and I get negative 1.28. Okay, next I'm going to substitute into the z-score formula. So I get negative 1.28 as my z-score. My x value is 15.9. My mean is what I'm solving for, and my standard deviation is 0.5. You could use nsolve again. I'm just going to do the arithmetic here. So if I cross multiply, 0.5 times negative 1.28 is negative 0.64. I subtract 15.9 from both sides, so I get negative x is equal to, I'm just going to take out my calculator, the handheld, because it's a little easier than going back and forth. And I get negative 16.54. I divide both sides by a negative, and my data value is 16.54, closest to 16.5. And the last one I'll go over in this video set is number 17. A distribution of scores is approximately normal with a mean of 78 and a standard deviation of 8.6. Which of the following equations could be used to find a score X above which 33% of the scores fall? So you're given a percentage, meaning that you're going to use a z-score. And another clue is if you look closely at these problems, the choices, don't they look like they're in like that z-score format? That's like another clue to help you out with this. Okay, so my mean is 78, but you see where they said, they said above which 33% of the scores fall? That means they're looking at that top 33%. The wording is a little awkward, but that's what they mean. So the first thing you want to do is find the z-score for someone in the top 33%. So remember, you have to convert to the percentile to use the function. And again, even if you're using table A, instead of the calculator, you would need to do that as well. So we go into our calculator and we do menu, statistics, statistic, distributions, inverse norm, and you're going to type 0.67, 0, 1. And when you do that, you get close to 0.44. You're then going to use the z-score formula, x minus mu over sigma. So the z-score is 0.44. My x value is what we're trying to find. My mean is equal to 78, and my standard deviation is 8.6. You could have also done this problem a different way. The choice is D. You could have plugged in each of these values and values to see which one worked, but this is the way I chose to do it. Have a great day.